Hi, my name is Brian Hall. I'm with Expiro, and I'm the Graph and Analytics Practice Leader. I'm going to be presenting today on introducing JanusGraph into your ScyllaDB ecosystem. And what I hope you learn today is all the things you can do with graph technologies, and graph databases. JanusGraph is the leading open source graph database, and it sings on top of Scylla. So you're going to learn a lot about different use cases, how you can use this technology, and it should be an easy on-ramp for people already familiar with Scylla. Hope you enjoy the talk. Normally we give these talks at graph conferences, and it was an interesting challenge for us to figure out the right presentation to do at a Scylla conference. We're kind of breaking this into two pieces, and my job is to introduce graph databases and graph technologies in general, get you excited and convinced that this is something that might be applicable for you. And then once I've gotten you all lathered up, then Ryan's going to show you how to actually use this or put this to use in your own ecosystems. So my name is Brian Hall. I am the Graph and Analytics Practice Leader for a company called Expiro. And in short, we build products for expert users. I usually say that if you want to buy something, put it into a shopping cart and check out, then we're not the right company for you. We usually like to build first-of-a-kind things that haven't been built before, and oftentimes those things end up using some exotic technologies like graph. We too, like the people before us, are headquartered in Texas, but we have people all over the country and internationally. We have two development centers in Europe, in the Canary Islands, Spain, and in Romania, which does a couple things. It allows us to service clients all over the world, but also provide some pricing flexibility where it makes sense. We do work in several industries, and what I say with respect to graph is if you have customers or if you have things that you sell and they are made up of other things, or you have any logistics that you need to worry about in order to get those things into your own hands to make your product that you take to market, then you may have a graph problem, right? So we work across all of these different industries, and you may look at that and you say, what do these have to do with anything? They're completely different. You have no industry affinity. A lot of the patterns and a lot of the graph use cases are very similar. Graph theory goes back many millennia. Actually, this is Leonhard Euler. He's a Swiss mathematician who is thought of as the father of graph theory. Back in the 1730s, he founded graph theory with this kind of the canonical, most famous graph problem called the 7 bridges of Königsberg. The idea here was there are 7 bridges going through different land masses, a river system in Königsberg, which is Prussia. Back then, Prussia is now Russia. And the question posed was, can I walk from each land mass over each bridge only once? Can I traverse all 7 bridges without doubling back on my bridges and cross only once? He was able to prove that this was not possible, founding that the number of edges coming out of any one of the vertices must be only either 0 or 2 of the edges can be odd. So that's the first problem in graph theory. So many of you looking at CQL or relational databases, what does a graph model look like? We have nodes or vertices. They point at other things called at other vertices, and they point at them through edges. I can decorate vertices and edges with attributes. I can make them represent just about anything. I could say this: Brian follows Door on Twitter, and maybe I want to decorate that with an attribute the day that I started following Door. I could also have it represent in a financial services situation. I could say Jamie owns an account of a type of home mortgage. Maybe I've got attributes hanging off of those edges that represent amounts, dates, rates, those sorts of things. I can also have that represent the fact that I have a financial advisor. Another one that we've actually done in practice, I can model malware. I can say this malware accesses different network resources. I can also say this is the behavior that the malware performs by adjusting registry keys, for instance. So how do I use these constructs and in what sorts of use cases? Well, the canonical example is in the social graph, right? So Twitter, I've got all sorts of people that follow me. I talked to somebody here from Facebook earlier today. Any sort of social network is a graph. I can model my customer base, right? So suppose I've got a whole network of my customers, and I can cluster them by type, and I can determine that maybe the red people up in the top left are professionals growing wealth. I've got empty nesters. I've got people with families. I've got wealthy business owners. I can represent these people in different types of graphs and treat them differently, right? I probably don't want to open up. I don't want to open up 529 accounts for my empty nesters, but I probably do for my family. So by clustering these different customer bases, I can treat them differently. Fraud and anomaly detection, that's another classic use case. I can represent, these are different accident cases. And is it interesting that I've got the same house in these two different traffic accidents, and the same Christina Porter is in both accidents, and Dr. Lowell Walters is also treating both of these people in completely different cases. Is that an anomaly? Is that fraud? I don't know, but certainly worthy of some further investigation. That's a classic graph use case. Recommendation engines, right? If my son buys a Spider-Man lunchbox, maybe he might also want a Spider-Man water bottle. Maybe other people the same age as my 10-year-old son, they might want the same thing. I can represent all of these things in a graph. That's a classic use case. Transportation networks, right? This is actually an example from one of our projects where I'm tracking road risk and road conditions to determine traffic patterns, the ability to get across the Bay Bridge, and how those might affect my insurance rates. Supply chain, right? If I've got a storm coming through the intermediate manufacturing site, what things are not going to get onto my counter at Target at the end of the month? This is a classic graph use case. Bill of materials. Bill of materials, we actually had an interesting project, a aircraft engine junkyard, right? So they service repair for aircraft engines, and if I have a certain number of bolts and widgets, and I have a service contract with one of the major airlines, how many refurbished airline engines for a 737 do I need to keep? And how do I keep track of that with all the probability of what's going to be going bad? So these are all classic examples of use cases that we use graph databases for. One of the other benefits of having several millennia of graph theory is that there's well-published algorithms and solutions available all over the web. These are just a few. You've got clustering, you've got shortest path, you've got PageRank, all kinds of degree and similarity. So they're there for the taking and easily grabbed off the web. One of the other things that you see in a lot of marketing right now is that graphs are very useful when used with conjunction with machine learning, because typically what you see is normal machine learning algorithms. I'll have some sort of feature vector that I can get normally from my flattened data set, but I can begin to decorate it with other attributes of my graph. I can take out certain degrees and certain graph computations such that I can have a deeper and richer a feature vector with which to do more accurate machine learning. So this is an area of hot innovation right now. Okay, so you said we're at a Scylla conference. Why are you talking to me about all this silly stuff? Let's talk about JanusGraph. So JanusGraph is an open source graph database that requires a pluggable data storage layer underneath the covers, and therein lies Scylla. So I encourage you to go to JanusGraph.org and see all about it, download it, and play with it. A little bit of history about how we got to where we are with JanusGraph. Back in 2009, the Gremlin query language, which is the lingua franca of JanusGraph, came into existence. JanusGraph had a predecessor open source project called Titan that was started in 2012. 2015, Titan 1.0 came out, and in 2016, Titan actually got acquired, or the company that created Titan got acquired by DataStax, and there was a bit of a pause, a lull in the action, and in 2016, Titan 1 was forked into JanusGraph. So while JanusGraph has not been out as a project for a very long time, it has its lineage in a lot of the Titan DNA. And as of 2017, it's already gotten a bossy Best of Open Source Software Award from InfoWorld, and that's how we get to where we are today. So what is the JanusGraph value prop? So we've got Linux Foundation open source license for a graph database with Apache Tinkerpop support, the indexing backend, the pluggable storage layer that Scylla provides, gives you all the ACID transactions and horizontal scalability that you expect because you're here at the Scylla conference. It is not fly-by-night. There are real companies really using this. If you go to the website at janusgraph.org, you'll see these. I happen to know these are all publicly declared JanusGraph users. We've worked with a few of these guys, and they are also using Scylla underneath the covers. So this is not a bleeding edge technology, but something that's actually in practice today. I know some of you out there are already using this and can probably attest over happy hour. And the nuts and bolts of JanusGraph, like I said, it requires a pluggable storage layer, of which there are several options. Quite frankly, Scylla is, I'm not just saying that because we're here, Scylla is the one that we have had the most success with and is the most performant. And then it also has a pluggable full text geospatial search layer. We frequently see it used with Elastic, but you don't have to use it with Elastic. And then I think to wrap up, why are we using NoSQL for this backend? You have this horizontal scalability, the data modeling, and the fast exploration of joins. So hopefully, with that little survey of graph technology and why it works with Scylla, that can convince many or most of you that there's a graph use case in your company somewhere, even if you haven't thought of it just yet. And if you're curious, I'm happy to take questions at the end about how you might be able to use graph in your company.